Okay, in this problem we are given a system of two masses. The first mass M1 is lying on a frictionless plane, which is inclined at an angle of 30 degrees. And this mass is connected to another box of mass M2, which is hanging over a massless frictionless pulley. We want to find the magnitude of the acceleration of each block. First of all, the acceleration of both blocks is going to be the same because this is one system moving together. So we just need to find the acceleration by applying Newton's laws on each box separately. And we can start with M1. So the forces acting on M1, first of all, are the weight, which is downwards, the normal, which is perpendicular to the surface, and the tension here applied by the cord to which the box is connected. Now we are told that we have a frictionless plane, so I will not consider any friction. So these are the forces we have. We can apply Newton's second law. Our system is moving, so it's important to show the direction of the acceleration. Now we're not really sure of the direction of the acceleration, but we can make a guess and say that the acceleration is downwards. Now, if our guess was incorrect, then we can just notice it when we get a negative value for the acceleration. If we got a negative value for the acceleration, this means that our guess of the direction of motion is incorrect and the acceleration is actually up the incline. Of course, once we put this guess for the mass M1, M2 will also have to be consistent with the direction that we selected for M1. So our guess for M2 must be upwards in consistency with our guess for M1. So let's just apply Newton's laws. I'm going to apply Newton's law along the horizontal because we're interested in the acceleration, which is along my x-axis. And I'm going to select my x-axis to be along the incline because this reduces the number of angles that I need to worry about. So this is my x-axis, and my y-axis will be along the normal because the y-axis should be perpendicular to the x-axis that I selected. So this is the y-axis. So I'm going to apply Newton's law for M1 along the x-axis. We selected the direction of the acceleration is down the inclined plane. So let's actually take this to be the positive direction. So along this x-axis, I have the tension force, and I also have the x component of the weight force, which is right here. Now, for the weight force, we can see that the weight makes an angle of 60 with the positive x-axis selected here. So we're going to have here plus W cosine 60 equals M1 times A. This is W1 here, of course. So this is our first equation. Now we can move forward to study M2. So for M2, if we look at the forces involved, we have the weight, which is downwards, and the tension, which is upwards. We have taken the acceleration to be upwards as well. So if we apply Newton's second law, we're going to get T minus W2 equals M2A. So this is our second equation. Obviously, we have two equations with two unknowns obtained now. This is equation 1, this is equation 2. So we just solve these two equations to get the value of the acceleration that we are requested to find in this problem. So, okay, so if we solve these two equations, let's start by substituting the tension that we have here in equation 1. So we will have minus W2 minus M2A plus W1 cosine 60 equals M1 times A. So let's rearrange this to get A. We get this expression for the acceleration, which we can now simply find by substituting all the values that we are given. So if we substitute these, we're going to get this expression for this value for the acceleration of each box. And you can notice here we have a negative sign for A, which means that our choice of the direction was incorrect. So we need to pay attention to the direction here. It is not down the incline. M1 is going to move up the incline while M2 will move downwards. So this was part A. In part 2, we are asked about this direction of acceleration. So now we can clarify that M1 will be up the incline, will be moving up the incline, while the hanging box is moving downwards. They asked us just for the hanging block, so we can just say the hanging block moves downwards. Okay. In part C, we want the tension in the chord. This is very easy because we got an expression for the tension in the previous parts. So we got that the tension is W2 plus M2A, for example, which can be written as M2 into G plus A. And we can just substitute this 2.3 kilograms into 9.8 minus 0.735, and then we will get the value of the tension to be 20.8 newtons. You can notice that the tension is 20.8, while the weight W2, if you calculate it here, it will be around 22.5, which makes sense. So the tension is 20.8, which is less than the weight, which is 22.5 newtons, which means that the box moves in the direction of W, right? So in this problem, we were able to calculate some values from the dynamics of a moving system. We found the acceleration, we found its direction, and then we deduced the tension force that is exerted by the rope to which these two boxes were hanging.